This video is going to help you review for your first quiz in Integrated Math 3, which is the first 4 sections of Chapter 1. And in sequence here, it's a pretty short quiz, and we only have a total of 12 questions. So this video, I'm going to describe and walk you through each type of question, and then you will have a question to answer for yourself to check to make sure that you have your that you're understanding each type of question. So the first one, you're going to find a rule for each pattern. So you can make a t-chart if you'd like to, because that's what a rule does. It shows a relationship between two things. Usually we use x and y. So we can let x equal the figure number, and then y equal, in this case, the number of circles. And then we can see if we can find a rule that would show, if we wanted to figure out how many circles there were in the 7th or 8th figure, we can just plug it into our rule and we would know how many there would be. So first of all, figure 1 has 2 circles, figure 2 has 5, figure 3 has 8, figure 4 has 11. And the way that I taught this in class is that if this is increasing by 1, and this, whatever this is increasing by, will be the rate, which we would always put the rate in front of your input or your x. So we know that the rule or function is going to have to be something along these lines. Now we might have to add or subtract something off of this to make it actually map. So to do that, we're going to look at the first order pair. Say, okay, when I plug 1 into this function, I need to get 2 to come out. So right now it'll be 3 times 1, which is obviously 3. So I need to subtract 1 to make that a 2. So that minus 1 is there. I'll put that in a different color. So you always just have to check, whatever you need to add or subtract. Sometimes you don't have to add or subtract anything, but to make sure that it maps. So you can look and see the rest of these order pairs will not work. If you were to times 2 by 3, you would get 6. Then 6 minus 1 would be 5. 3 times 3 is 9. Minus 1 is 8. 4 times 3 is 12. 12 minus 1 is 11. So really, if you triple the x and then take 1 away, you're going to get y. So then this 3x minus 1 is a rule for the pattern. So if I wanted to figure out how many circles there were in the 10th figure, you would do 3 times 10, which is 30, and then subtract 1, you say there'd be 29 circles. So the key there is what I have there in red, is to make sure that the pattern is always going to increase by or decrease by something. And then that value needs to be in front of your input. And you may have to add or subtract off of that to make the relationships work. Okay, next is the types of real numbers, all the sets of real numbers that we have. When we talked about this in class, we had a Venn diagram to help us understand. So I'm going to just abbreviate over here. So on the outside circle, that was our rationals, which is all of our fractions, but also all of our integers, which is no fractions, but it has negatives and positives. Then you had your wholes, and then inside there, you had your naturals. And then outside here, you had your irrationals. So that's just a quick sketch. But rationals, again, are also integers, wholes, and then naturals. I'll even color in that little circle there to stand for naturals. So there's another set inside there. But integers would be no fractions, so that'd be all your negatives and positives. Wholes is 0 and up, and naturals are 1 and up. So, and then irrationals are the decimals that go on forever and don't have any pattern to them. Okay, so as I look at question number 2 and I ask, what are the integers? I'm going to look, okay, Integers are the ones that don't have any fractions in them. So that would be -1. That would be 0. That would be 81. And there's a trick question there, also the root of 25, because the root of 25 is just a 5. So those would be all my integers. If the question said, what are my whole numbers? Well, my whole numbers then are 0 and up. So I just have to get rid of this one. If the question said, what are your natural numbers? That's 1 and up, so you'd have to get rid of that one. And if the question said, what are the rationals? Okay, well, rationals is everything that's not irrational, so that's a lot. So that rationals would include your fraction, right? Pi is irrational, so is the root of 5. Because the root of 5 is a decimal that goes on forever. So those would be all your rationals. So just a quick review of it all. Integers are no fractions, but they can be negative and positive. So this would be your final answer. So -1, 0, 5, and 81. All right, we've got some properties, and we had a lot of properties. Now this one here, all we're doing is changing the grouping. Notice that we're not changing the order. So this was misconfused quite a bit in class when you did 2 times 5 and 5 times 2 are both 10. Right, that's the commutative property where you actually switch the order. So don't get that confused with number 3. This one here is the associative property because you're changing the grouping. So on the left side, you have the 2 and the 5. And then on the right side, you have the 3 and the 2. But the order on the left is still 3, 2, 5, 3, 2, 5. But you're changing the order. Number 4, you're taking the 5 and multiplying it to both terms on the inside. That is the distributive property. Okay. So we had a bunch more than that, but as far as this review goes, those are the only 2 that are being reviewed. All right, so now we're going to talk about expressions. So here we have the sum of y and the product of 7 and x. And every time you see these ands, that shows what we are summing and what we are multiplying. So here we're going to sum y. So sum is addition. And, okay, now we're going to add the product, which is multiplication, of 7x. So we can write multiplication just right next to each other. All right, so 8 more than. So 8 more than is another word for addition. Quotient is division. So 8 more than the quotient. More than the quotient of t and 2. Okay, so I would write it like that. If you choose to use the division symbol, you can do that as well, because order of operations would tell us that we would have to divide by 2 first anyway, and then add 8. So that would be okay. But the first one's the most common way of solving that. Okay. Also, a little side note that we had in class that was tricky is that when it said when you have 2 operations back to back. So, like for example, if I were to switch product and sum here, so the product of the sum, that's where you're going to have parentheses. So I write the expression. So if I had this expression here, just making one up, in the words, it could say, I want the product of 3 and the sum of x and 2. So, so you're taking the product of a sum. So when you have that back, those word product of a sum back to back, or product of a difference, which then would switch that plus sign to a minus sign, you gotta have to have parentheses there. So really watch out for those scenarios. Okay, next we're going to use substitution. So we're going to plug in, and every time we see a b, we're going to put in an 8, and then we're going to use order of operations to solve. So when I plug 8 into this expression here, I'm going to have 2 times 8, 16. All right, so I went ahead and did that, and then I'm going to go ahead and do the parentheses as well. So again, I'm going to put the 8 in place of b, so I'm going to have 8 minus 4, and I'm going to have 4. So next part would be to multiply. Don't do 16 plus 6. You want to do addition. Or sorry, do the multiplication first. So 6 times 4 is 24. And then we can add 16 to that and get 40. Okay, next one. All right, now you got to really watch the negatives. Make sure you keep track of all your signs when you do here. So when I plug -4 in, I got -4 minus 1. Now, since these are all numbers, you technically don't have to distribute, but you could go ahead and distribute that if you wanted to make that -8 minus 2, which would be -10. Or you could just go ahead and do order of operations and do your parentheses first. So you'd have -4 plus 2 times -5, because that's -4 minus 1, and then 2 times -5 is -10, like we would have if we would have distributed it. So adding a negative is like subtracting. So -4 plus -10 is like subtracting 10. So 10 more to the left, and you got -14. Number 9, you're going to give an example of a number that is an irrational number, and then explain why. So the main examples that I would have for here, most common is pi, but also all the roots that are not perfect. So square root of 2, square root of 3, square root of 4 I'm not going to do because that would be 2, so that comes out nicely. So root of 5, root of 6, root of 7, root of 8, root of 9 I would have to skip because that would be 3. Okay, so those are all decimals that continue. So so as far as your explanation goes, that would work. It's decimals that don't stop. Okay. All right, now the last part, we're going to solve equations. The first thing we do before we use our properties of equality, which properties of equality says we're going to add, subtract, multiply, divide things to both sides, is to simplify. So with number 10, I have a distributive property to do first, and now I can't simplify anymore. As far as the left and the right side go, I can't simplify any. So I'm going to use my properties of equality, and I'm going to start trying to isolate x. Now here I have an x on both sides. So the key is I want to make it a 0. I can make the 2x a 0 by subtracting 2x, or I can make a 4x 0 by subtracting 4x. Either way would be okay, as long as you realize that you need to use the subtraction property. And let's move on down into number 12 so I have enough room to write this. You want to make that 0 because I know 0, this being 0, 0 minus 2 would still just be -2. All right, now again, I'm going to make this 0 also. And I'm going to continue on down, and I'm going to have 10 equals 2x. Now I want to make that a 1 because I know 1 times x is going to be itself, or its identity. So I'm getting it by itself. So x is 5. I would do the same thing for number 11. I would just simplify by distributing first. You get 6 minus 6y. But again, I have a variable on both sides. So I would have to either add 6y to both sides, or subtract y. But you have to get these y's together, and do not use division to do it, because again, we want to make that 0, because 6 minus 0 is still just 6. 1y plus 6y is 7y minus 8. I'm going to add 8, which gives me 14. And then here's where I can divide and get 2. Because again, that is your identity there. When you do 7y divided by 7, that's a 1y, which is just y. Okay. Last but not least, we have a story problem in which you will have to find an equation first and then solve. So write an equation to solve the problem, then solve the equation. Brandon has $3 more than Mark. So we have some unknown values. We don't know how much Brandon or Mark have, so let's throw in some variables for each one of them. Now let's set up the relationship that sentence sets. So Brandon has 3 more than Mark. So however much money Mark has, if I add 3 to that, I'm going to get how much Brandon has. So that is that relationship. And now we have a third possibility. We have Ashley. Ashley has $10 less than Mark. So however much Mark has, if you take 10 away from it, you're going to have how much Ashley has. And then they have $35 together. So I know that if I were to add all 3 of the Brandon, Mark, and Ashley together, it's going to equal 35. So this is going to be our substitution. We're going to have to, in order to solve an equation, we cannot have 3 different variables. We can only have 1 variable. So I already have b in terms of m. And I can also, if I add 10 to both sides over here, I will have, well, that'd be getting m by itself. So that would be m equals a plus 10. You could have also got just kept a as that, but either way, you're just going to have to make substitutions to the point where you only have 1 single variable. Okay, so I'm going to use, in fact, now that I think about that, let's just leave that as it is. And then I can have an equation of just m. So if I put m plus 3 in for b, so I'm going to have m plus 3 right there. Then I'll keep my plus m already there. And then I'm going to take my a, which is already m minus 10, put that right there. Now, after making all those substitutions, I have just 1 equation. Now I can figure out how old Mark is. And once I know how old Mark is, I can figure out how old Brandon is and how old Ashley is, or how many dollars, sorry, each one of those would have. So m plus m plus m is 3m. 3 minus 10 is negative 7. So we would first, like as always, when solving equations, we simplify. And then we use our properties of equality. So we want to make that 0, because 3m plus 0 is just 3m. And that gives me 42. And then divide to make that a 1m. So Mark has $14. So now that I know Mark has $14, I can plug that back in for B. So, or sorry, plug that back in to find B and A. So I know B is 3 more. So 14 plus 3 would be 17. So Brandon has $17. And then Ashley has 10 less. So she's only going to have $4. Because if I plug it again, if I plug that in, 14 minus 10 is how much Ashley would have. And that's okay. So Ashley has 4, Brandon has 17, and Mark has 14. Okay. Now you could have technically rearranged those to get a function of all b's or a function of all a's. I just chose to get a function of all m's. And then that's how we can use substitution to solve real life story problems.